Today we will study the PN junction diode as a rectifier. This is the application of PN junction diode. So this shows that the PN junction diode can be used as a rectifier. So what is a rectifier? Rectifier is a device which converts AC power into the DC power. So AC power generally at our home we receives the AC power from the power station, nearest power station, or power grid we receives the AC power. But mostly electronic devices operates on the DC power. So at low voltage also, but at input at our home we receives the AC power of high voltage 240 volt or 220 volt approximate and 50 hertz frequency. But electronic devices operates at low voltage, approximate 5 volt, 12 volt of DC power. So we have to convert the AC power into DC power. So that's our electronic devices can operate on DC power. So we have to require a device which converts AC power into the DC power. So here PN junction diodes can be used at that device which converts AC power and the DC power, and that device is known as the rectifier circuit. So this circuit shows that this circuit shows that at the power supply, this circuit shows that at power supply we use the we receives the AC power. But this is the block diagram of power supply circuits which used in the electronic circuits. So the main components of the power supply is transformer, rectifier, filter, and the voltage regulator. So the AC power is received the transformer of the power supply, which converts the AC power into step down voltage, step up or step down. So depends on the which transformer is used. Either we use step up transformer or step down transformer. So mostly step down transformer is used because input voltage is very high, and here we have to convert the low voltage. So generally step down transformer is used. So transformer is used. So this transformer will secondary of the transformer is connected to the rectifier circuits. So we can say the input of the rectifier receives the AC, and this AC of rectifiers convert into the DC power. This is the DC power, but this is not pure DC. You consider that DC is the pure constant voltage. DC is constant voltage, but this is not. You can see that this is not constant voltage. So we can say that the rectifier circuit not contains pure DC. It contains some contents of AC also. So we have to filter out these AC components from the output of the rectifier. So the output of rectifier is connected to the filter circuits, and the function of the filter circuit is to filter out the components of the AC components from the output of the rectifier. Now the output of the filter is approximate pure DC power, but this DC power is not constant. It will fluctuate according to the input. So we have to regulate it because the electronic devices operates on the constant voltage. So here this output of the filter circuit goes to the voltage regulator, which provides the constant voltage, to the electronic devices. So all electronic devices contains power supply circuits, and in power supply circuits a rectifier is a main component which converts AC into the DC. So again, what is the function of rectifier? Rectifier converts the AC power into the DC power, and PN junction diodes is the main component of the rectifier, which is used to rectify the AC signal into the DC signal. So there are two types of rectifier. There are two types of rectifier. One is half wave rectifier and another is full wave rectifier. And full wave rectifier is again converted into the center tapped full wave rectifier and bridge rectifier. So we have to study the half wave rectifier as well as center tapped full wave rectifier and bridge rectifier, and we have to also compare the output of each type of rectifiers, and what are the advantage and what are the disadvantage of these rectifiers. So you have to remember that there are two types of rectifier: half wave rectifier and full wave rectifier. And full wave rectifier can also divide into two parts: center thread full wave rectifier and bridge rectifier. So this is the circuit diagram of a half wave rectifier circuit. So half wave rectifier circuits use only one diode. This is the diode which is used in half wave rectifier. This is the transformer. This is transformer. This is the primary, and this is the secondary. So when the input voltage is appeared, what is the function of a rectifier? So first, one diode is used in half wave rectifier. This is the transformer, and this is the load resistance, at which we will measure the output of the rectifier. So input is applied in form of AC. AC contains positive part and negative parts. This is positive part and this is negative part. So first we will study the what happens with the when the positive cycle of the AC is applied at the input. So when the positive cycle so when the when the positive cycle will appears at the input, same input voltage will be also appears here. So this will be positive. So in this way this will be positive and this will be negative when the positive cycle will be. So we can say the A point is positive and B point is negative. Now the A point is connected to the arrow of a diode, and B point is connected to the bar of diode. So arrow is positive with respect to the bar. So we know that when arrow is positive with respect to the bar, diode will be in forward wise, and when the diode will be in forward wise, it will conduct the current. It will allow to pass the current through it. So the this input current or input cycle can flow through the diode through the load resistance RL. So when the input cycle will appears at the output resistance, we will get the output voltage here or output current here. So when the input current flows, diode will allow to flow it because the diode is in forward bias. So this current will flow to the forward direction. So output will received at the load resistance RL because the input flows through the resistance RL. So we will receive the output because the diode is in forward bias in positive cycle. Whatever when the diode is in when the diode is negative cycle appears. So when the negative cycle appears, this negative cycle will also appears. So A will be negative and B will be positive. So what happens now? A is connected to the arrow and B is connected to the bar. So arrow will be negative and bar will be positive. Hence the diode will be in reverse bias. And when the diode is in reverse bias, it will not allow to flow the current through it. The current cannot be flow through the diode. So the current cannot move to forward. And since the current cannot flow through the resistance RL, here the current is 0 because the diode cannot permit the current to flow through it. So current cannot pass through the load resistance RL, and since I is equal to, so V out is equal to 0. So this part, the negative cycle will not flow through the diode. So we can say that the negative cycle of the AC, in this circuit the negative cycle of the AC will be blocked and positive cycle of AC will be flow. In this way we can say that when input cycle positive, output is be received at the output. When the input is negative, the output is 0. So this part cannot be flow to the diodes. So hence we only receive the positive part of the signal at the output. So we can say that this is the only we will get the flow of current only in one direction. So we can say that this is a DC, because in AC the current flows in both directions, positive and negative. But here the current flow only in one direction. That's where we can say that the DC. But the DC, we know that DC is a constant. This is not pure DC. So this part of the rectifier is not pure DC. It contains some components of AC also, due to which it has the fluctuation behavior. So now we have to filter out this the AC components from the output of the rectifier circuits. So this output of the rectifier circuit goes to the filter circuits, and filter circuits will filter out the AC components from the output of the rectifier. So at the output of the rectifier we will find out the pure DC components. So this is the half wave rectifier, and in this rectifier you can see that only the positive part will be received at the output and negative part will be 0. So in this way the its efficiency is not 100%. What is the efficiency? Efficiency means how much power of AC. Efficiency means how much power of input AC power can be converted to the output DC power. How much AC power can be converted into the output DC power? This ratio is denoted the efficiency. So eta is used to denote the efficiency. So the efficiency of the rectifier can be the output of the rectifier is DC and input of the rectifier is AC. So eta can be defined as the DC output power upon AC input power. And when we will calculate the efficiency of rectifier, after calculation we will find out that the half wave rectifier converts only 40.6% AC into DC. Only 40.6% of AC is converted into the DC. So means the efficiency of 60% of the input power is wasted, because approximate 60% of the AC power is wasted because that power is not received at the output. So this is the main drawback of half wave rectifier. So in next lecture we will calculate how we will drive the efficiency of half wave rectifier. Okay.